What's up everybody, I'm Jason and welcome back to the channel. So this video is going to be a supplement to my video which was tip 56 for the EOS R5 tips series, where I was looking at the creation or the setup for FTP and FTPS on the camera. And in that video I largely glossed over any of the detailed computer related stuff that you might want to or need to know if you were setting up your own FTP server or FTPS server. I only covered in that video the bare necessities or bare minimum that you needed to know if assuming you already had the server set up or knew how to set the server up and have it running. So in this video, we're going to talk about TLS certificate creation with the software that I use, which is called XCA. Now, before I get into talking about the details of this, I do need to talk really briefly and clarify a point on the theory of all of this. So in my R5 video, I may have implied that self-signed certificates are not as secure as certificates that are signed by a certificate authority. Cryptographically speaking, this is not true, and I did not intend to imply that. Cryptographically speaking, whether the certificate is self-signed or signed by a certificate authority, it doesn't matter. The same encryption will be used. The strength of the encryption that's used will depend entirely on the encryption itself, not necessarily not the certificate or who signed the certificate. That said, what I mean to say, or I want to be clear about, is the integrity of a self-signed certificate situation versus that of a certificate signed by a certificate authority is entirely a situation depending on your ability to validate that certificate. So your ability to know whether that certificate is in fact the certificate that, say, you created, and therefore you should trust that you are actually connected to the correct server. I should say all of this comes down to what your connecting device, so your camera, your web browser, whatever, presents to you to enable you to validate the certificate that you're using, or the certificate the server you're connecting to is using. So in the case of, for example, your web browser, it will present you with a huge swath of information, the common name, the fingerprints, a ton of stuff from that certificate that you could be able to verify, because obviously when you created the certificate you know what those things are. Like, you can have the fingerprint for your certificate written down. And so when you connect to the server, if you see your fingerprint is that you wrote down is the same as the fingerprint the server is saying that the certificate has, then you know you're connecting to the server and you know that the connection is secure, that there isn't a man-in-the-middle attack happening between you and that server that's decrypting and then re-encrypting the traffic with a different certificate. This is where the camera falls down. It doesn't give you that information. So if you're using self-signed certificates with the R5, then you have no way, none of the standard mechanisms, or in fact no mechanisms exist really, for you to verify that the certificate that you're being presented is in fact the certificate that you created and installed on your server. There can be a man-in-the-middle attack. Now, this is mitigated to a large extent by the fact that the camera can't connect across networks due to other issues, but we're talking assuming that gets fixed, right? With the certificate authority signing your server certificate, you could install that certificate authority certificate in your camera as a trusted root, and that will verify, the camera will use that to verify that the certificate that it's being presented by the server is in fact signed by that certificate authority's certificate, and therefore is not being attacked in the middle. It's a level of verification that the camera can do or does that just doesn't seem to exist, or doesn't exist in the standard or in the self-signed configuration. So when it comes to making certificates, there's kind of two options in the broad scope of things. I'm sure there's a whole lot of other ones out there, but I have not run across all of them, and I'm not exactly an expert in all of the options that are available. But the big one that you will see pretty much on every tutorial for doing this from anybody who does a tutorial on doing certificates is going to be OpenSSL. It is easily the industry standard for doing certificate stuff. It's what like I said, everybody is going to show you in a tutorial. The alternative that I'm going to be showing in this video is a piece of software called XCA. And it is a GUI certificate creation and management app that is built on top of OpenSSL. So it uses OpenSSL under the hood, but it abstracts away all of the problems that I have with OpenSSL into something that's easier to use. Now, what is the problem with OpenSSL? Well, the problem isn't OpenSSL, the problem is me. I'm a photographer. I'm not a network administrator. I don't do certificate TLS certificates regularly, and OpenSSL is not designed to be easy to use. It's designed to be incredibly powerful and incredibly capable, and it's certainly going to be something that a lot of people, or that people can be very familiar with if they use it frequently or constantly on a daily basis or weekly basis in the course of, say, their job. But that's not what a photographer is about. I don't make certificates. I don't sign certificates. I don't manage certificates. I take pictures. So the short of it is that OpenSSL presents long, complex, arcane commands that are not entirely obvious that you have to know and understand to be able to do anything. And if you don't do it regularly, you have a tendency to forget all of that, or at least have to have huge cheat sheets to be able to go through and do all of the processes using a cheat sheet because you haven't done it for a year. XCA manages all of that complexity under the hood. You fill out the forms essentially for what information you need to provide to the certificate, so you still have to understand that process, but you don't have to understand whether it's OpenSSL X509 or OpenSSL something else or minus whatever, command line option. You type in things, you hit OK when you're ready to go. So let's jump into XCA and take a look at how this all works. So this is the user interface for XCA. I have not created a database, and that's the first thing that we're going to do in this demo is create a database to be able to do this stuff. So we're going to hit new database. I'm already, where am I? I'm already in my demo folder, so we're going to just call this demo, and we're going to hit save. And all of your certificate databases in XCA are password protected, so we're going to just set a password. In this case, I set test because I'm going to just delete this. It's a demo. It's not my actual certificate system. And so this is the database. You have obviously a list of all the private keys you've created. You can handle certificate signing requests, either sending them out to be signed by an external certificate authority or signing external certificates at, that requests that you got. You have a list of all of the certificates that you've created. You have templates that you've created that are outside of the default, which is a useful thing for administrators. And then you have the revocation lists, which again is an administrative thing that we're not going to be dealing with here. So the first thing that we're going to do is we're going to create a self-signed certificate. Now I know I said don't use these, but I'm going to show you how to do it anyway, just because. So we're going to go new certificate. We're going to say under signing, create a self-signed certificate. We're going to select TLS server or default TLS server under the template, and we're going to hit apply all. And we're going to jump over to subject, and we're going to set a subject or an internal name. So the internal name is not something that gets applied or used in your certificate. It is only used in XCA so that you can understand what things are when you're looking at them. Now, the distinguished name part of the certificate is something that you normally would absolutely have to fill out as much of this information or most of this information for your certificates to be approved or work, or even in the case of generating certificates that you're going to put up on a website, some of this information has to be filled out for the browser to even consider the certificate properly. Again, the context here is producing a minimum viable product to make the R5 connect to an FTPS server, and it doesn't check any of this stuff, so I'm going to just do the worst practice thing that you could do and leave all of this stuff blank. Generally, you wouldn't say to use that. Every certificate needs a private key, so we're going to hit generate new key, where the name for the key is automatically going to be a copy of the internal name that your certificate is assigned. So the key and the certificate have the same name, makes it easy to find. And we're going to say key type. You have 4 choices of key types: RSA, DSA, ecliptic curve DSA, and Edwards curve. That's the last one. So EC is ecliptic curve and Edwards curve is the last one. For the ease of making things work with the R5, choose RSA. The camera doesn't support DSA certificates at all based on when I was looking at what the camera says that it will support for key exchange. It says that it will support ecliptic curve DSA key exchange, but I couldn't get that to work. I don't know if it's a problem with the camera or a problem with the way I was doing things, but I couldn't get it to work, so I don't recommend doing that. And the camera can't deal with Edwards curves at all, as far as I can tell, so you don't want the Edwards curve, the last option at the bottom. Go with RSA. It's the most widespread compatible option that you're going to have in dealing with the R5. Key size. You have 4 options: 1, 2, 4, and 8 kilobits. I am not going to get into the ins and outs and the nuances of the crypto and the stuff behind the crypto that the cameras have to, or that what key sizes and everything are most secure. I'm going to sum it up with this. My understanding is that right now, a 4096-bit RSA key is considered reasonably secure for the foreseeable future. That could change because this is a field that's always evolving, especially as new compute power is available, GPUs, quantum computing, all of that stuff. The camera had no problem when I used 4096-bit keys, so just that was a safe place for me to go based on my understanding of key security and the current state of crypto and crypto breaking. So we're going to generate the key. The computer will come back and say that the key was generated, and we're going to go to the extensions page. So the first thing we're going to do is delete the subject alternate name. Now, if you were doing a web server, you would need to have subject alternate name. It would need to be your DNS for the server or your IP address for the server if you're connecting to it. That's stuff that your browser checks to ensure things are working correctly or that you are connecting to where you would think you are connecting. It's stuff the camera doesn't pay any attention to, so I'm going to get rid of that so I don't have any problems with it. Finally, I'm going to backdate the certificate by a day. This is to work around a bug that I found on my camera when I was dealing with it, which is, for some reason, the camera does not like GMT certificate times, or it thinks local time is GMT, or I'm not entirely sure what the problem is on the camera. But the short of it is that if I set a certificate to be valid, say now, the moment I create it, and then I put it on my server, and then I connect to the server with my camera, say in 5 or 10 minutes, the camera, it will not work. The camera will reject the thing as not being a valid, or being not valid, due to the not valid before time. If I backdate that, I did it by a day when I was testing. I didn't go any further than that. If I backdate the certificate for the camera, it works fine and I can use it immediately. So that's what I'm doing here. And then just to show what's going on, the template sets all of the key usage stuff that needs to be set for the certificate. The rest of this stuff we don't really need to deal with. There is a comment field if you want to add a comment for your certificate beyond just what the default comments are. And we hit OK. And the XCA will come back and say that this is successfully created a certificate called Demo Self-Signed Certificate. It'll tell you that it's not a certificate authority. It has the serial number for the certificate, and it tells you that it expires in September of next year. There's your self-signed certificate. You can export it, put it on your server, export it in the key, put it on your server, and go from there. But I said we should use a certificate authority and to sign a certificate so that the camera can actually have a reasonable attempt at validating it. So that's what we're going to do. So step 1 is creating the certificate authority. Now this is a lot like the self-signed certificate in a sense, because the certificate authority certificate will be self-signed. However, for the template, we are going to choose default certificate authority, or CA, as opposed to the TLS server or TLS client. And we're going to jump over to the subject page, set our internal name. Again, you would fill out all of the distinguished information, or distinguished name information typically. I tried checking to see if any of this shows up on the camera when you look at the root certificate statistics, or not statistics, details. None of it actually showed up. So I didn't display the organization name, didn't display the organizational unit name, didn't display the common name. It has a field that in theory is supposed to display some of this, but it didn't display any of this information. Of course, we need a key, so because I've got this defaulted, because I checked default after setting up the first key, we will hit create 4096-bit RSA, good safe option for making sure that the camera works. Under extensions, we are going to backdate it a day again because I need to make sure that this will all work on the camera today. I don't want to have to wait until tomorrow. The certificate has a 10-year life. The key usage is all what it's supposed to be based on the template, and we hit OK. And we have created our demo certificate authority, and it is recognized as a certificate authority by XCA. Okay, now we need to create the server certificate. So we go through the process again, create a certificate. Only this time, because we have the certificate authority selected, it will automatically set the signing to be used this certificate for signing with the demo certificate authority in the drop-down list. If you didn't do that, so let's just not do that, hit new certificate, you can manually select use this certificate for signing demo CA, and it will do the signing. It'll sign it, use the demo certificate, or use your certificate authority, in this case it's called demo CA, to sign your certificate. Again, this is a lot like the first time. We're going to do TLS server, apply all, give it a name, fill out the distinguished name information, generate a new primary key, or a new private key. Again, 4K-bit RSA, make sure everything works happily with the camera. Go to extensions, backdate the start time or the not before validity time, and delete the subject alternate name so we don't have any problems because the camera doesn't check any of that, and hit OK. And it says the server successfully created the certificate. If we spin open the little arrow next to the demo certificate authority, you see the FTPS Server Certificate is there. So the last thing that we need to do is get the certificates out of XCA and into something that we can use for our stuff. So the first thing we're going to do is we're going to export the demo certificate authority. This is the root certificate that you would install on your camera that checks to make sure that your server certificate was in fact signed by that. So we're going to select it. We're going to hit export. We're going to change the path just for this demo to demo, and we're going to change the name to root.crt. Why root.crt? Well, that simply is because that's what the camera looks for when you copy it to an SD card. Root.crt, root.pem, or root.cer, if it's not named one of those three things, the camera won't find it and load it. So I'll just save it out as that anyway, to start with. Export format, we want to make sure that this is set to PEM with the CRT extension. That doesn't include private keys. It is just the certificate, and that's the only thing we want to have that we put on our camera, and we hit OK, and it's exported. Now for the server certificate, things are similar but slightly different. So we're going to hit export. We're in the demo directory. This time we are going to export as PEM plus key, star.pem format. This is the unencrypted concatenation of the private key and the certificate in one file. It's what the TLS server software that I use is most easily dealt with. Normally, if you were transmitting this or sending this or transferring this across networks or whatever, you'd probably want to use an encrypted format and then decrypt it on the far side, or make sure your software supports decrypting it with the password and so forth. I'm not doing that. I'm going to say that that would be a good practice, but I'm not going to say that it's super important or essential. So we are going to, again, put this in the demo directory. We're calling it FTPS Server.pem, and we're going to hit OK. And if I swing over to the demo directory, you see here, Demo.xdb is the the XCA database file. FTPS Server.pem is our certificate and private key that needs to be used with our FTPS server. And root.crt is our root certificate that signed the FTPS server certificate that we put on our camera so that the camera can validate that the root or that certificate is what it says that it is. So this is server certificates or TLS certificates kind of in a nutshell with XCA. This is basically what you need to know. Minimum viable product to make the R5 connect to a server over FTPS. So if you found this useful or at least interesting, let me know by hitting that thumbs up button or like button. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you're not already. And as always, thanks for watching, and I'll see you next time.